Hey, good morning, guys. This is Dr. Jean Son from Healthy Sprouts and House Calls. I've been wanting to do this video for a very long time, and I've told people it would be coming, but I was super busy with seeing patients and running my business, and I really didn't have the time. So I decided last night and this morning, that's it, I'm gonna carve out time. But basically what I want to talk about is the vaccine that's going to be coming out. Well, two vaccines, one from Moderna and then the one with Pfizer that received emergency use authorization, and people in the general public, so to speak, mostly in healthcare, started receiving it yesterday. So I get questions from people all the time, and the first thing that I want y'all to know is I am in the Pfizer vaccine trial. A lot of people on my personal Facebook know this, but sharing it beyond that, I got the first dose in August and the second dose in September. It's a blinded trial, so I don't know whether I got placebo or whether I got vaccine, but I can tell you that I feel pretty confident that I got vaccine. And the reason I feel pretty confident was after my second injection, I did have the listed side effects that they describe, which honestly, fever, chills, I had muscle aches. I did have a little bit of sore throat and kind of a clearing my throat type of cough. And I would do it all over again. I did not take a Aleve or ibuprofen or Tylenol. I wanted the full punch. I wanted to see what the side effects felt like, and I wanted to make sure that there were no chemicals that potentially interfered with the immune process that I was experiencing. So add that to the fact that they test me before I go in to see if I'm positive, and they draw antibody on me. And I have been in the homes of people who are infected with coronavirus on a regular basis, really up close and personal during their own testing, and I have not been sick. This is huge for me. I have asthma. I have moderate persistent asthma. I'm on inhaled steroids and Singulair every day. And with flu, I actually teeter-totter on am I going to need to go in the hospital or not. So this was really momentous. I didn't go in the vaccine trial for me, although maybe the added benefit ended up being for me. I did it for my patients. I did it for grandparents across the country. I did it for our world. And I believe in the vaccine science. So there's a lot of misinformation, and I just wanted to go over in a way that I felt like people would understand, because one of the things people tell me is, all our doctor friends post all this information, but like we don't really get it. And people have been asking me really, really good questions, and I can understand why people would be hesitant. But the problem is sometimes those questions stop there, and you're getting information from people who don't know what they're talking about. So there's danger in that too. And so I just want to make sure that I go over this with you. So let's talk a little bit about coronavirus. So coronavirus, we've all gotten used to the way it looks with its spikes. It is an RNA virus, and when China first struggled with it, their scientists worked really hard to figure out the genetic structure of the virus. Because if we know that, then we can kind of understand how it functions and try to make it hard for it to function. And regardless of your politics, I don't really care about them, China did share that genetic information with the world, so that the world could get working on what can we do about this virus. And so people figured out that this little spike, as I'm sure you've heard of, also has like a genetic instruction book, okay? And the scientists know that little spike is like the grappling hook for the virus to get into our body. And a lot of times when we make vaccines, those are the proteins that we target. We target the grappling hooks because we know if your body can make antibody to those grappling hooks, then we can either lessen the burden of infection, so you might not get as sick, you might not go in the hospital, or we might be able to prevent it altogether. And so they figured out the genetic structure of this protein, and what they've done is they have used like an instruction manual basically, and given it to the body and said, here's how to make just that spike, just that protein. so that the body can recognize it and develop an immune reaction to it and hopefully prevent infection. Now that instruction manual is something called messenger RNA. Messenger RNA might, you might vaguely remember it from high school, or you might not have heard of it before, but it's not new. It's in lots of animals, including us, obviously. It's in the viruses. And it performs the function of being an instruction manual or a recipe for proteins that we use on a regular basis. So they figured out how to take that messenger RNA of the spike protein, not the whole virus, just the spike protein, and wrap it in lipid being fat, right? They wrap it in that. Now, why do they wrap it in fat? Well, our cell membranes actually are fat loving or lipid loving, and so when they see a fat particle, they'll say like, hey, why don't you come on in, right? So they made this at messenger RNA, wrapped it in this fat particle, and they put it into the vaccine, right? And here's our mRNA instruction manual. So I got an injection in my left shoulder, and then that mRNA wrapped up in fat floats around my body, and my cell says, hey, why don't you come on in here? You look like a nice fat particle. And that mRNA goes into what we call the cytosol of the cell, or the cytoplasm, okay? Now, one of the questions that I commonly get, and I think it's a really good question, is, well, I don't trust that vaccine, or I don't understand that vaccine. It's going to go in my cell and it's going to change up my DNA. Well, it won't. It doesn't. It won't even go into the nucleus of the cell, which is where DNA lives. Our body doesn't even have the proteins to allow that to happen. So if people are telling you that, don't listen to those people, because they don't really understand cellular biology and how it works. It's not going to go there. What it does, that messenger RNA goes to what we call ribosomal RNA, or the ribosomes. And you can think of ribosomal RNA, if we go with the analogy of the instruction manual, they are like the factory, and it takes that instruction manual and it makes proteins. If you use the kitchen analogy, that it's DNA is the cookbook, mRNA is the recipe, then ribosomal RNA is like your kitchen, and it's where you're going to make that product or that protein. So our body reads that mRNA and through the ribosomes makes a little spike. And then that spike comes out to the edge of our cell, just like it's on the edge of the virus. And there are a bunch of immune mediators that are involved, and I have just made it as slim as possible. Okay, so it's much more complex than this idea. But what happens is T cells mark that spike protein because they recognize that is not self. This is a foreigner. We don't like this guy. He needs to get out of Dodge, right? And so T cells actually start the process of destroying that spike protein, and it communicates with other cells to help give us memory. So down here, we can think of T cells as like our first response and part of transport. And I like to liken it to like your Amazon immune delivery truck, right? So it's an immune delivery truck that helps to deliver it to B cells and other cells. And B cells will kind of act like our photographer or our record keeper, sort of like when you go on Amazon and you ordered something but you don't quite remember it, so you go to your order history, okay? So this is kind of the role that B cells play. They help us with memory of this spike protein and that it was a foreigner and a bad player, but also in the process helps to make antibody. I think most of us understand what antibody is, but antibody is just a natural part of our body, right? So it helps fight off infections, stop them at the door. And so we are using, in the most natural way, our body to help try and prevent ourselves from getting coronavirus. So the next common question that I get is, well, that sounds bad because that mRNA is going to come in and just make spike protein over and over and over again, and our body's going to always think that's foreign, and that's like bad, right, Dr. J? Well, that's the beauty and the brilliance of the scientists who decided to use this technology, which is new to us, it's not new to them. They've been working on this for years and years and years and years, and they even worked on it with the SARS and MERS epidemics that had occurred. So mRNA in our body is kind of recycled and gotten rid of on a regular basis, right? So we have mRNA that's made from our DNA, leaves the nucleus, goes into the cytoplasm. When it makes its protein and its function is done, it gets disposed of, okay? It goes away, and whatever components that are kind of left over get recycled or expelled in our body. And that's done in something called the lysosome, right? So here I've drawn like a little trash can. So lysosomes are like the trash can of our cell. And I like to liken it to the trash can on your computer, like literally. So just imagine that constantly, every day, even our own mRNA, but also the mRNA that we get in this virus, after it makes the spike protein, it goes away, like just like on the computer when you put it in the empty trash bin. And that is a regular process that already happens. So spike protein is not sitting, floating around in my body right now. It's gone. But the memory of it and my ability to make antibody to it, it's still there. Okay? And so, some of the other questions that I get is, and this is before this vaccine, but parents oftentimes or adults are worried about adjuvants in a vaccine, or what some people, would think of as additives. This is part of why I am so behind this mRNA vaccine is, really this is like fat, and some complex sugars and some sodium in these vaccines. That's part of the reason why they have to be kept so cold, is to preserve them in the process. But all those things that everybody's been worried about, antibiotics that are added, that tiny bit of formaldehyde, which is less than you would ever eat in a pear or an apple. And by the way, our body actually makes small amounts of formaldehyde normally. That's not in this vaccine. It's not there. It just isn't. So I think people need to understand that this is kind of the vaccine technology that you've been waiting for. The other question that I get a lot about was like, well, this was so fast. We're not really comfortable with how quickly this rolled out. I don't know if many of y'all know, Dolly Parton donated about $1 million to Vanderbilt and the Moderna trial. And she did that. She knew a scientist who has been working on coronavirus and working on treatments and vaccine-related science for coronavirus for 36 years of his life. You can look him up on YouTube. He has really great lectures on this. But this is new to us, but it's not new to the scientific community. There are other vaccines that are already in significant phase 3 trials and cancer treatments for melanoma and lymphoma using this vaccine technology. Kind of one of the differences here is, SARS was new, right? So we had to learn how to make a vaccine for SARS. But the difference here is a bunch of people stepped up to the plate, right? So a significant number, I think the number's around 43,000 so far for the Pfizer trial. And the reason I say so far is because they dropped the age of the trial, and now they're studying kids 12 and up. So it's not over yet. We're still looking at information. But a lot of people stepped up to the plate and put their arm out there and their body out there to try and combat the problem and the pandemic that we're seeing. That's not a small number of people, and it's comparable to other clinical trials that took a long time. The other thing with response to time is a lot of our other vaccines are grown from cell cultures. So a chicken embryo or some type of other cell, and that is a very tedious and long process. That's why, every year with flu vaccine, it takes a while before it becomes available, is because they actually have to grow it in the lab, which is almost like watching grass grow. You don't have to do that with this vaccine. There's no growth in cell culture. It can be produced, and it can be produced pretty quickly in the laboratory. And so I think, if you're not certain about that, the information is out there, but you have to go to the right people to find it. Okay. I hope this clears up some things. I'll do another video kind of in more detail of my personal experience with going and getting the vaccine and why I did it. And then I'll try to shoot another video at some point in time answering questions that people have relating to, well, I'm breastfeeding and should I get the vaccine, or, I'm pregnant, or I might be trying to get pregnant and should I get the vaccine, or what about children? What about my 16-year-old? And when might it be available for younger children? And what will the trials look like for that? Okay. Anyway, all hate mail can be sent to Greg Johnson, my husband. No, I'm joking. If you have a concern, just please be kind in your concern. And you can email me, healthysproutsandhousecalls@gmail.com, and I'd be more than happy to have a one-on-one conversation with you. Thanks. Bye.